Hello, long time no see. I am back with another video. I intend to cover topics around traces on Ethereum, and of course, uh, this would definitely apply to all EVM, especially the new Kaya data, right? And the reason why I'm doing this is because I feel that there's not much usage on the traces table, and I feel that there's a lot of information that you can extract from the traces table that aren't available in other people's analysis, which could be something that could set your analysis apart from others. So let's begin. As I go through this, I'm sure there'll be topics that I missed out, and so I'm just gonna do like several parts for traces. So we'll see how it goes. Now, first thing I want to do is I want to give an overview of what the traces table is. I'm just gonna select all from and let's do a quick limit 10. Now, the way you can think about traces is it is a I guess in this case the traces table. It is a table that records all things, all the operations and all the steps and immediate steps, or like intermediate steps I should say, that the EVM does to process a transaction. So I have a transaction here, which is an NFT sale on Magic Eden. I'm going to go to this site called Falcon, or rather app.blocksec, and then paste my transaction hash. And what this site does is it gives you a nicer view to visualize traces. Okay, so essentially this is traces, right? It records all the possible steps, not possible, it records all the steps and that the EVM does to process your transaction, right? And yeah, let's go to the columns in the table. So standard stuff, transaction hash, block number, block timestamp, from address and to address. Would be which address is the one that called, or called the other address, right? So in this case, this address called this address, and then what is the uh, data. So maybe it's easier if I write it out for you. So if you want to make a call, let's say like a if call method, you will need a from address to address, and then like the data itself, and this data would have your function signature, and then followed by all the data, I guess. So for example, if you are sending ETH, oh sorry, if you are sending, let's say this is yeah, sure, why not? If you're sending ETH, right, this is a ETH send. You are sending from whatever this address is to this address, and then your data, right? In this case, the data will be just 0x because the ETH transfer function has no data. But if it's something like a, let me just find, where is it? Okay, this one, where it's a weth transfer, it would look something like yeah, there you go. So it would look something like uh, from address sent to whatever I guess in this case is the wrap ETH address, and then the data will look like it has a function signature. In this case, it's transfer from, and then all the bunch of data. So the raw data will look something like this, right? You have your function signature and then a bunch of I guess data, and this data How do you know exactly what data this is? This would go back to the contract itself. So you would have to match this function to the contract, to the function within the contract. So I'm a bit going sideline here, but let me just quickly go into this. So wrap ether transfer from function. Go to wrap ether's page on etherscan, and then I'm clicking on contract, and I'm gonna view the contract. So search for transfer from, and I'm looking for function. So this is the one, and let's see. Yeah, so it requires an address, which calls src or source, and then it requires another address called destination, and then it requires an integer. So if we look back at our call data, this would be the first address, which is src source. This is the second address, destination, and the third address is the integer, which is in this case is how much weth is being sent. Right. So from address to address, how much weth is being sent. So hopefully that gives you an overview of what exactly is in what exactly the data looks like when it is visualized like this, right? In this case, it's all shown nicely, and that's what the from address and to address is, right? So from address is the address that called so in this case the address that called the transfer from function on wrap ether. So your to address will be wrap ether, and then your input, this input over here, would be the function signature followed by the data, right? Which is this thing over here, function signature followed by the data. The data is address integer, right? Okay. All right. So what else is in the traces table, right? We have value. Value is the amount of ETH being sent in this specific trace. It can be 0, it can be non-zero. And then we have 2 extra columns because sometimes the values become very small, and so to keep the precision, we just have these 2 columns to keep its precision. And then gas is, of course, what is gas actually? Surprise, I forgot. But it's a standard, like what you will see in the transactions. And then there's 2 things called input and output. So input is what you send, and then output is there can be no output, but output is essentially, let's say you're doing a read, like you're reading the Uniswap pool, a specific pool's balance, and so you're sending in information like to the pool. Let's say the function is called balance of. So you're sending in input saying my function signature is balance of, and then my data is what is the pool address that I want the balance of, right? And then the output would then be the actual balance, like the EVM would evaluate and say, okay, the pool balance is so and so, and then that comes out in your output. And to know like what is the structure, you can just refer to the API of the contract. Maybe we can take a look, if I remember. Okay, the other thing I think that's important is called type, so that you can do several types of calls, I guess. One of it is just call. You can think of this as like you're telling the function to do something that it is designed to do, right? So let's say in this case you're telling the wrap Ethereum contract to execute this function, and so that would be a call, type call. There are also others. For example, delegate call. In this, like what I've written here, delegate call. One example of this is, let's say your contract. Let's say you call a contract, and the contract itself doesn't have the core functions. It relies on another contract to, that has all the functions. And the reason for that is because maybe you will want to upgrade the contract, and you can just change what you call these implementation contracts. And so your main contract, aka your proxy contract, remains the same. And whenever you want to upgrade, you can just ask the proxy contract to make a delegate call to your upgraded implementation contracts. I'll talk about this and give more detailed examples. But another thing to keep in mind is from the type, you can do several things. One is, of course, to find the implementation contract. Another is to find where contracts are being made. So if you do a select distinct type from the traces table, you will see that there is a type called create, and also create to, right? These are just the different trace calls you can call when you're creating a contract. And then identifier, honestly, the for me, what I find useful would just be the call origin. So this is just means, so let's say in this transaction, it's a bunch of calls, right? Call origin just means the first one over here, like the initial call that you made to the contract. An example would be, let's say you are on Magic Eden's website and you interact with, let's say you click buy, right? And you approve your transaction on MetaMask. This would be your address. This would be the contract that you just click approve on from your MetaMask. And literally this is the call origin, right? And so you have identify over here. Right, so in that same example, that Magic Eden example, this contract then goes ahead and makes a delegate call to another contract, because this contract itself does not have the necessary functions to do a forward call. And then this function does another call to another contract, and ultimately does another call to this final function over here, which is the which has all the information that we want to analyze. Okay, so identifier not that important, except for call origin. Data is just exactly what you sent to the contract. No guess use input. Sorry, not send, but like what is, I guess, sent and returned. So you have the output as well. So all these are just extracted out already over here. So you have input, output over here. And then I think last two things. One is trace status. A transaction can be successful, but the trace failed. That is common, right? Even though the trace failed, it doesn't mean the whole transaction failed. You can have a trace that failed, but the transaction still goes through. One example is, let's say there is this function here called royalty info, right? You're trying to ask whether this NFT contract has this function, royalty info. If it doesn't, then it just fails, right? So this whole thing will say fail, but the other functions and events still takes place, right? Depending, if this is not affected. If this is not affecting the other functions. And then last but not least is trace index, which is in this particular transaction, what is the order of trace traces, right? Literally just the order of traces. Some small things to know is what we call like sub traces. Not that important, but just for just extra knowledge. It just means like it tells you the hierarchy. So if, for example, this origin call has one subtrace, which is just one over here, because there's no more others here. However, this particular trace, right, trace index 3, has more than one subtrace. It has 1, 2, 3, 4. Events are not counted. So 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 subtraces for this particular trace index. Okay, so now that we know what sort of columns exist in traces, how do we make use of traces? I was thinking of what examples to give, and I guess it would be helpful for me to explain how does events come about. So, right, like how does events related to trace? Okay, and maybe I can show the can show it on Etherscan. So Etherscan, you have internal transactions, which is traces, right? All these all the traces, right? And then logs are just event logs. And but if you look at block seg over here, it shows the events within the traces, right? Why? This is because whenever you write a function, let's say the wrap ether contract, right? Whenever you write a function, you can also choose to emit an event, and that's why when and if you look at the weth contract over here, the function transfer from emits this event called transfer. I actually looked it up, like why does this not have the word emit, because if you look at other contracts it would have emit, and it's because this version of Solidity does not have emit, the word emit, but after 4.20 there is emit, so it's less confusing. But notice how this is a capital T, and so if you scroll up over here it says event capital T transfer, and so this is actually referring to the event which is defined above over here. So this says whenever this function is executed and all the checks pass, emit this function called transfer. And so that is why when this call function is succeeded, the event transfer is emitted. And this event is this event is exactly like what is defined in the smart contract over here, where it says source, destination, and I guess what. And so source, destination, and what. So that's how events relate to traces. Okay, so again, events are, I guess, just information that can be emitted. You can define like when to emit them and what information to emit whenever a function is executed, right? What this also means is that events or the developers who created the smart contract may not emit all the events, emit all the information in events. They can just choose to emit some information in the event. And so that's why there's been some discussion, I guess, a few months ago uh, on Uniswap trying to remove all events to save gas, right? So that's one consideration why you should learn traces. Okay, so where am I? Okay, so I guess what will be helpful for me to show is how does this exact trace look like. Okay, so I'm going to put that in my traces table. 616. So I already have a query here. I'm just gonna comment out some stuff. Let's see. Okay, so what am I doing? I am just getting trace index. Right, we saw trace index from here. I'm getting the input, which is the function signature plus data sent to the contract. I'm getting the output, if any, right? It could be null. And because I know the first 10 characters of input is the function signature, I'm just going to do a left input 10 as my function signature. And then if you follow my other videos, you should be familiar with this regex, which essentially just cuts every 32 bytes, which means every 64 characters into chunks, into arrays. Into an array, so that it is very easy to manipulate the data. So I'm just gonna run this. I'm also seeing that the date is 6/16, so this should be 16, just so I can get the query faster. Okay, so what I like to do is I like to arrange this into ascending order, so I can see all the trace. And then I'm going to filter by function signature. So my function is, I want to find the transfer from function. So this would be this over here. And function sig is this. So I'm filtering by transfer from. And because I know that I want weth, I can also filter for weth by saying the to address is weth, because I'm calling the weth function with the transfer from. Sorry, I'm calling the weth contract with the transfer from function. Okay, so we see 12, 13, 14. And so there are 3 weth transfers. Let's confirm that on here. So 1, right, transfer from weth, 1, 2, 3. So there is indeed only 3 in this transaction. And what else? Yeah, so that's basically how you would pull out the trace that you want, which is find the function signature, find the to address, and then in some cases you can even filter by the type, which is call. Some cases you need to filter by the delegate call type. In this case, I don't have to. And so how do I make use of this data? You would go to the input, right? And we've already chunked out the inputs into something called segmented. And so we would just have to use this array. And how do you know like what is what, right? We will go back to do that, we will go back to the function itself. So one way is you can just read from the contract here. Another way is, you see how it says address uin. It takes in 3 parameters, address, and uin, which should mean that this is an address type, this is an address type, and this is an integer type. So that's how you would read it. And then src, this is the name of the parameter. So this is source src, and dst for destination, and then what is because it's just naming. That means it needs to be divided by 10 to the power of 18, but it is an unsigned integer. Another way is you can just scroll all the way to here where it says contract API, and then you copy this whole thing, go to this website called JSON Beautify or Code Beautify, and then paste, and then search for transfer from, which is the function. Right, make sure it says type function, right? And then again, it's the exact same thing like what you will see on the contract itself. There are three things in the input. The first thing would be an address type with this name. Second would be address type with this name, and then third would be an integer with this name. And so given that we know the type, we can then change this data according to the type. Okay, so what I mean by that, so let's go through this. So if I were to do segmented 0 like this, I'll pull the first element in the array, right? And because I know this is an address type, I can just take out the first the zeros in front. I forgot, I think it's something like 25 or 24, I forgot. Let's just run this and see what we get. So it should be F602. Okay, so it is 25. That's right. Okay, so because it's an address, so I need to add 0x in front. So something like 0x and then concatenate. So this will give me my address. So let's double check this in Falcon block scan. So the first call, the first input is a address, and it's 0x f602, which is exactly what we see here, right? 0x f602. There you go. Let's move on to the second one. With the second one, we know it is an address as well, so we do the same thing. And we know this is called DST because in the API or in the contract it's called DST. And last but not least, we have this hex that's supposed to be of integer type, right? Unsigned integer. So we will just convert this hex to int. You can do something like is it live query.utils udf hex to int. So I'm just converting hex to int with this function, and there you go. So let's verify, right? 1 to 88. So go back to my Falcon block scan. We can see that this call is 1, right? And then 2, and then 88, right? That's it. That's basically how you would extract the specific trace and then convert its type based on the contract or based on the API. Okay. Another thing I'm noticing is that there is the transfer from evaluates to true. So whatever on the left side of this arrow is input, and whatever that's on the right side is output. So the output is true. So if we go back to the contract or API, it says here output it's a boolean. So we can go back to our output and see that it is indeed 1, So one boolean is true, 0 is false. Okay, so that's basically how you would convert input and output according to these types. Okay, cool. Let's do something more complicated, which is how do I get this information instead. So this transaction is, where is it? Okay, so this this transaction we're looking at is this transaction over here on Etherscan. Basically, this address accepts an offer on an NFT, and this is the address that made the offer, and this address accepts the offer, and the address sends over the NFT and also receives money from the NFT sale, right? Oops. And so let's look at the events, right? So the event that correlates to the sale is this one over here, where it says accept offer. We have a seller address, buyer address, token address, which is the NFT address, token ID. Beneficiary, I'm guessing, is the person who receives the money, or NFT, I'm not sure. Payment coin is, I guess, the currency address, and then sale price is the total sale price. So one thing you will notice is that it doesn't tell you anything about the fees. Like, what about platform fees? What about royalty fees, right? Although it has good information like seller, buyer, NFT address, currency, sale amount, and people usually would use the event logs, they would be missing out on other information. In this case, what is the royalty and what is the platform fees? And so that's where we would use traces. If we look into the trace, it's this one over here. And I'm just going to scroll to the right to see what information is available. So right off the bat, I'm seeing some stuff like this thing called is collection level offer true. I guess it evaluates it true. And then there is a protocol number, a marketplace, a fallback royalty recipient address, an expiration date or timestamp rather, marketplace fee numerator, so this would be the percentage of marketplace fees, and then max royalty fees, and then some signatures. So okay, and then extra stuff called fee on top. So right off the bat, you can see there's so much more information here that is not emitted as events in event logs. So that's how, and so if you're able to extract all this information, that is how you're able to, just present more information in your analysis, right? Okay, so let's look into how to analyze this. First thing I'll do is, how do you even know like this is the specific trace you want to analyze? One is try to follow the origin from address. So the origin trace is this, right? It makes a call to this, and normally there's only one delegate call, but in this case you can see that the function name is called forward call. Whereas if you look at your transaction, I'm sure here is function forward call as well, but if you look at transaction, it's not exactly forward call, right? Like it should be something along the lines of like accept offer, and so that gives you a hint like this is not the final I guess trace to look into. Another thing is also, if you're able to see like all the variables already written up for you, like in this case it says, you know, like sale details, everything. This means that blocksec is able to find the uh, ABI for the contract, and so it's able to decode all this for you already. Whereas this, maybe the data itself or the contract itself is not verified, or maybe the data it is gibberish, right? So they're not able to decode it. So that gives you a hint like, oh, this is not the trace. Whereas this trace module accept offer function has all the information you need. So that's how I would like zero in on this particular trace. So let's go back to maybe I'll call this as like weth transfer in traces. Then I'll create a new query. It's gonna copy some stuff. Let's see. So I don't want this function signature anymore, right? And I don't want this to address. So what do I want? So I want this function signature instead, which is this over here. And then I want this address instead. So this is always your to address, right? This is to address, this is to address. Your from address is the address before it. So in this case, if the parent is this, and this is the subtrace, right? You can see how it's like below it, like so. The from address will be this, the to address will be this. So I just want to grab to address here. And then here's where we can use the type, and type equals to delegate call. And then comment out all this, and let's just run this and see what we get. There should only be one result, and yep. Before we begin, just quick one. The way to get all of the possible functions is something like so of course remove the transaction hash and then change the date to, I don't know, when the contract is started, right? But in this case I'm just gonna do like June, right? Obviously not accurate, but and then you can just do a qualify partition by function sig, right? In this case here, transaction hash, and then I just give me the latest. Oops. So what this does is give me all the functions natures from based on these parameters, which is the to address being the module traits contract, and then it's a delegate call to this contract. So just give me all the functions natures, and the reason why I do this is because you can have a example transaction hashes where you can paste on to block explorers like blocksec to see like what is this trace about. So for example, if I were to paste this first transaction hash, I see that there is a contract, there's a function called bulk by listings, right? And so now I can, you know, put this into my put this into my like notes, and this is called bulk by listings. And you can do the same for the rest of the transactions. That way you can get all the possible functions that are being called to the contract or to the address that you're interested in. Alright, okay, so I'm going to remove this and go back to my query, which is this and this. Okay, So where were we? Okay, we were here, right? Accept offer. Now, the first thing I will do, or I guess the next thing I'll do, is I would click on the contract itself, and then go to the ABI. Okay, there you go. Go to ABI, copy the whole thing, paste on our trusty code beautifier website, and now you have all the ABI nicely here, and you can search for the contract now. So the contract that we want is accept offer, right? So I'm just gonna search for accept offer. Not this because it says event. We're looking for function. Again, not this. There you go. Type function accept offer. This is the one that we want. We see that there's no output, and then there is 6 stuff in the inputs, right? I guess 7. And if I were to do like this, you can see, yeah, in inputs itself there are like 7 things. And then we can try, and based on this, we can then use this to make sense of the data, right? So the data looks like this, very ugly, but hopefully let's try to make sense of it. Okay, so another thing I like to do is I like to, once I've made it into these chunks of 64 characters, you can just copy this, and again, our trusty website. Oops. There you go. So now it's nicely in this vertical format that you can check easily. Okay, so let's try to do the decoding. Okay, so first thing on the API is something called a domain separator, and it is 32 bytes. The way you interpret this is it just takes up 32 bytes. And so if you look at the first 32 bytes, the whole thing is just domain separator, and we can confirm that right, 366C, confirm that on blocksec. The first thing is domain separator 0x366C, right? So that's done. Not needed to write down, so I'm not gonna write it down. The second thing is boolean. So go back to here. The second thing will be boolean, so this is true because it's 1. Not important. And then this is where there's a bunch of stuff here called sale details, and it's a tuple, which means it just accepts a bunch of different types of data types. One thing you have to be careful here is that there are no arrays. So here it says uin 8, right? But if it says uin and then like square brackets, then you have to apply the array rule, which is something like it tells you how many bytes you should offset, and then it tells you how many elements are in the array before the actual information itself. But maybe I'll do that in another video. I don't think this I'll cover it in this one because it's getting too long. Alright, so let's move on. So the first component is called protocol, and it is an integer. So let's look at here. So again, this is the bytes, sorry, domain separator, some boolean, and then this is the protocol integer. So in this case, it's 0, right? So if you want to write it down, you can. So something like segmented 0. This is to main separator, and then segmented 1. This is collection level of right, no idea what that means. And then the second one would be protocol. Yeah, I'm realizing that maybe making the commas on the left side is easier. So I'll just do that. All right. So what's the third one? Address. So this is address. So what do we know about address? We need to use this substring thing. So I'm just gonna copy this, paste it here, and then change this to 3. Right? And the address name is maker, so call this as maker. Right? So simple as that. Yeah, basically just go down the list, and because we already made it into an array, it should be pretty easy to just extract it, and then based on the type, if it's an address, follow this substring and then add the 0x in front method. If it's an integer, convert from hex to int using this function over here. I think that's pretty much it, right? So let's just see, like address, uint, so just convert it to integer. And then maybe this is interesting, expiration, which is an integer, but because we know it's a time, we can convert it into time. So maybe I will do this. What number is that though? So maker is 3. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, okay. This is called expiration. Yeah, so let's just run this and see what we get first, and then we'll do the toTimestamp function. Alright, so let's see. I should probably comment that out, but okay. So right, so the first thing we have is the domain separator, right? And then this is the is protocol level offer, it's a boolean. And then this is the protocol number, no idea what this means. And then we have our first stuff, which is called maker. I guess it's the maker address. And then again, verify whether this is the same on blocksex. So maker F602. And if you scroll here, it would say yeah, maker F602. Right? So that tallies. And then we have expiration, which is the in Unix format, and we can convert this to timestamp. So you can use the toTimestamp, and that should give you a timestamp. There you go. It expires on July 16 at this particular time. Okay. What else? So other stuff that could be important would be things like marketplace fee, and then max royalty fee, right? And yeah, basically just go down the list, and then I'm guessing you don't need the signature, so this is not needed. Not needed as well. And then this is co-signature, again, not needed. And then the last but not least, there is this thing called fee on top. So you do have to count how many and make sure there are no arrays. I don't think there are any here. And then lastly, you would have this thing called fee on top. And that's it. yeah, that's how you will use traces to extract information and then convert it based on their data types. You will know the data type by going into the address of the transaction, sorry, the contract of the transaction, and then go to its ABI section, copy paste them into this website so they can see all them nicely over here, and then grab your input, which you have converted into um, chunks of 64 characters long in an array, paste it here so you can see it nicely, or I guess easier to see. That's it. I'll be covering more topics in the next videos on traces, so stay tuned for that when I do get to it. That's it for this video. Thanks for watching, and leave a comment if you find this interesting or if you have other topics to recommend. Bye!